interface 7 segment display in it and count 0 to F on it. So in the kit, actually 7 segment is this. Okay, so this is actually connected to port number 126 pin. This 7 segment is connected to port number 127. This is 28th and this is 29th pin. 4 7 segment displays are there, and I told you can check the where actually it is. You can see 7 segment. If you have any doubt, you can see this is the 7 segment. Okay, display unit 1 is connected to port number 126 pin, second is 27, 28 pin and 29 pin. These are selecting which display, and the data for the 7 segment display is given from port number 2, 0th pin, first pin, 2, 3, 4, 5, 6, 7. So totally 8 pins. So 8-bit data you have to send to 7 segment display. And the circuit for the connection, you can if you want to show only one display, only one transistor, you can show port number 26 pin is connected to the first 7 segment display, and this data for this display is given from port number 2, 0th pin to 7th pin. Okay, so these are some current limiting resistors. So this is now we'll go to the program. Before going to the program, we have to send values to this 7 segment display. How to give values for 0 to F, because we have to display 0 to F now. So we'll show the first construction of the 7 segment display. So why it's called a 7 segment display is it has 7 segments. Okay, here the connections are, this is 7 segment, segment A, segment B, segment C, segment E, F, G. Totally there are main segments are A to G. Okay, A, B, C, D, E, F, G. So this is used to represent, you can display any segments on and off, and you can show a display of alphanumericals. Okay, you can display some of the alphabets and some all the numbers from 0 to 9, and this is used for dot point, decimal point representation. So this is actually there are pins available in the 7 segments. So these are actually this G, no connection, this to G segment is here. For this F, this is the connection. For this A, connection is here. For B, it is here. For E, this segment, it is here. D, it is here. C, it is here. And decimal point P is here. Okay. And this is a COM, and this is also COM, ground pin. So same order you have to write here in the table. Okay, you have to write like this only. So G, F, A, B. How to remember? You can see here. First, if you write, think this G is here. Start from G like this clockwise. Start from G. G, F, A, B, and here start from anti-clockwise here. E, D, G, and DP. Or you can do it. This is you already continued with, started with a G, F, A, B. No, so continue with P here. Okay, anti-clockwise. P, C, D, E. P, C, D, E. In between here we have COM. You leave it. So right here G, F, A, B, P, C, D, E. Like this. G, F, A, B, P, P, C, D, E. And after that here we have, there are two types of configuration you already studied in the theory. Okay, common anode and common cathode configuration. So here I think we are using common I think 1 means on or off, you can see here. This is actually G, and for display 0, to display 0 segment, G and uh, decimal point should be off. That means G is 1 and here P is 1. So that means 1 means off here. Okay, 1 means off. So 1 means off means you can check it out whether it is common anode or common cathode. Okay. So it is anode common anode configuration. In the common anode configuration, all the anodes are connected to the plus 5 volts, and at the other end, if you give 1, both the ends are with high, so output is 0 because the diode becomes reverse bias. So 1 means off, 0 means on. So it is common anode configuration is used. In the Viva they will ask which configuration is used. So in the common anode, 1 means off, 0 means on. Another configuration is common cathode where 1 is on. Okay, here common anode type 1 means off. So G and P, that means this segment and dot segment should be off, remaining should be 1. Now you group this, since it is data bit is 8 bit, it is connected to port 2.0 to port 2.7. So we are to give these values, so we have to give it in hexadecimal value. So group first 4 and second 4. 1000 means 8, one here also 1000 means 8. Now in order to display 1, to display 1 here, B and C should be on. So B and C should be 0. B and C should be 0. Remaining segment should be off. So we will give remaining segments A1, B, A1, G1, F1, E, F and AP 1. Then all the segments are off. Only and B and C are on because only these two are given with 0. So now group 1110 is E, 1011 is B. Okay. So hexadecimal digit up to 0 to 9 it is same. 10, 11, 12, 13, 14 are capital A, B, C, D, E. No? So 1110 means E. Okay. So similarly to represent 2. To represent 2, A should be on, B should be on, G should be on, E should be on, D should be on. So only these segments should be 0. Which are the segments should be off? F should be off, C should be off and P should be off. So FCP should be given with 1. F is given 1 means off, no? 1 means off. So this is off. Decimal point is off for all the segments and E is also off. So that will display 2. Similarly for 3, F, E, P should be off. So give with 1 value. Similarly, you write code for all the values up to F. Okay, up to F. For 8, you can see for 8, okay, for segment 8, only decimal point is high. Only decimal point should be high. So you'll get 0000, only decimal point is high because we have to turn off. 1 means off. So code is 0, 100 means 8. Similarly, you can type code for F is 1E. So this is you have to give these values to from port 2.0 to 2.7, which is connected to the data pin. So this is how to write code for 0 to F. Okay, we are giving data values here, and to enable this, you have to select which segment by using this. So which the first thing is we have to configure port number 26 pin as output and port number 2027 pin as output because you have to send some values to this. So let us go to the program now. Display X digits 0 to F on 7 segment LED display with an appropriate delay between the count. So include LPC 17xx.h. XX means 1768 we are using, so that comes under the 17 series only. Unsigned char data 7 segment. This is the name of the array. Initialize the arrays with values of 0 to F code. So this is the code for 0. EB is the code for 1. 4C is the code for 2. Like that. 1E is code for F. So you have to write hexadecimal value now. So that's why you have to give 0x. 0x indicates that it is a hexadecimal value. 88 is an hexadecimal value. This 1E is also hexadecimal value. So that's why you have to start with 0x. Okay. So these values are written from this table. These values 88, EB, 4C, 49, 2B, 19. All values from 0 to F values you have to load here. and the array name is given as, you can give any label, 7 segment values or data for 7 segment, any level. Here I have given data 7 seg array initialize with 0 to f values, int main void unsigned int ij, initially count is equal to 0. Now you have to configure now port to 0th pin to 7th pin. You have to configure as output, so you have to put those values as 1. So LPC underscore GPIO port number 2 dash greater than mark. You have to, for configuring input output, you have to use FIO-DIR. You are using FIO-DIR, and last 8 bits 1111 1111. After grouping, you are going to get FF. You can exclude this zeros and you can simply write 0xFF also. Okay, so that is configuring port number 2 0th pin to 7th pin as 1, or if you want to write using OR operation. Okay, so you have to do 1 left shift by 0, or with 1 left shift by 1, or with 1 left shift by 2, or with 1 left shift by 3, or with 1 left shift by 4, 1 left shift by 5, 1 left shift by 6, 1 left shift by 7. So that actually becomes lengthy. Okay, so instead of that, write 0th bit to 7th bit as 1111 and group and form a hexadigit as FF. So this will configure 0th bit to 7th bit of port 2 as output. 1 means output, 0 means input. Similarly, we have to select any one 7 segment, no? So we are selecting only port 1 26th, so which is connected to the first display unit. Okay, if you want to display in second, write 27 here. If you want to display in third digit, 27 you write 26, 27, 28. And if you want to display in the last one, write 29. Or if you want to display in all the 4, do OR operation here. Okay, 1 left shift by 27, or with 1 left shift by 28, or with 1 left shift by 29. Then count will come in all the 4 7 segment display continuously. Okay, so next while one means this is also continuously infinite times. It is the count will 0 to f 0 to f 0 to f, automatically it will count for infinite time. While one, if count is greater than f, that means we have to count from 0 to f only, no? So that's why you have to check whether the count is reached maximum count of f. Okay, if you want to count 0 to 9 only, that is a BCD counter, instead of f here type 9. So that will count only from 0 to 9. Here this indicates that this is a maximum count. If count is greater than maximum count, here it is here f, then you have to reset the count value to 0. If count is greater than f, initialize once again count with 0. Else, okay, for I is equal to 0, this is a delay. Okay, between one count to another count. If you want more delay, you give more value. If you want less delay, give less value. Okay, for I is equal to 0, I less than 20,000, I plus plus. Okay, what it has to do, LPC underscore GPIO2 is given with a value. Okay, FIO pin, we are not giving set or clear here, we are giving some value, and that value is actually given from the array. Data 7 segment is a data 7 segment is a array. In this array, actually first count, first value you have to send. Initial value of, what is the value of count value? Count value of initial value of the count is 0. So in the 7th the data 7 segment array, 0th value is this. This is the first value, second value, third value, fourth value. First is this. Okay, data 7 segment of 0th value is this. This is the first bit. So first initial value of the count is 0. So it is going to fetch the data of this value 88. 88 data is there, no? Hexadecimal 88. That value is going to given to port number 2. Okay, and these pins 0 to 7th pin, and that is going to display immediately 0 on the 7 segment. And after that, we have to first set that value and reset. Okay, uh, which segment we are displaying in 1, no? So GPIO 1 port number 1 26 we are going to enable by making set and call delay for small time, and for this small delay there is no statements, so that's why you have to put semicolon here only. So this indicates that open bracket, close bracket, no more statements. If you want, if you don't want semicolon here, write one open flower bracket followed by close flower bracket. So that means this for loop is not doing any execution of any statements. So that's why semicolon is put here. Don't put here. Okay, this should execute these codes, but this is used for only delay. So for this for loop, semicolon you have to write here. Remember here. Always remember the for loop which is used for delay purpose. For that one only you have to put semicolon. Okay. Next, here we set we set this one and we call some delay. After that, we have to clear that segment. Otherwise, the old always it will display same number only. So you have to clear it because we have to display second value. After this, what we are doing count plus plus. So in the count plus plus, actually it is a C is actually case sensitive. So this should be small c. By mistake, while pasting, it's coming capital. It should be small c. Count plus plus will take place, so it will incremented by 1, and after that check count is greater than f or not. After increment 1 becomes 1 is less, 1 is greater than f. No, it is not true, so don't execute this. Okay, only if the count is greater than f you have to do this. Otherwise what you have to do, you have to display once again for I is equal to 0, I less than 20,000, I plus plus. So you have to do this. Okay, so this one now GPIO2 is given with a new value. Count is incremented here. Count plus plus. So count value is now 1. Now actually port number 2 is given with a value, pin value, which is data 7seg of 1. I told no. First element is 0th element. Next is first element. So next data we are giving is EB. EB is the code for 1. And that one value is given to JPIO2 from pin number 0 to 7. So that will display 1 in the 7 segment. Again, you have to set the first segment, call delay, and clear the first segment. Okay. So after that, again count plus plus. So that will increment. Again count is less than f. So it will execute this. It will display 3 now. Because it is going to fetch count of 2. This is the code for 2. It will display 2 and again count plus plus. So this will repeat up to what? After f. It just after f the count becomes 1 0. Once it reaches f here, once the count reaches f here, f is not greater than f. Okay, f is not greater than f. So that time it will reinitialize the value to 0. So after f, once again it will reinitialize the count value to 0, and again it will fetch the data segment of 0 only. So 0 to f it will display. After this again count is reinitialized to 0. So it will fetch 0, 1, 2, 3, 4. So this is about 7 segment, and in the 7 segment you can see here for 126th pin the count you can observe in the last right side 7 segment. If you want to see in all the 4, do OR operation here wherever 26 is there. So 3 lines we have one left shift by 26, one left shift by 26, one left shift by 26. If you want to display in all the 4, do OR operation, right? Vertical line pipe operation, OR operation, one left shift by 27, again pipe operation, one left shift by 27, 8, again pipe, one left shift by 29. All the 4 you have to do OR operation. Here also all the 4 with pipe operation, all the 4 with pipe operation. And then if you execute, you can find, you can observe a 0 to f count in all the 4 segment. And if you want to increase the delay between the count, here you have to vary. Instead of 20,000 you give 40,000 or 50,000. And if you want to count only 0 to 9, that is Bcd counter, instead of f you write 0 to here you write 9. Or sometimes if you want to display some characters, instead of display 0 to 9, if you want to display FISH fish, write code for FISH using this table. Write your own code. For example, code for F is this 1E. FISH, I means this no 1. So write EB as the code. S looks like this. Okay, 5. So write 19 and H, write H code, you only write that H code and load the 4 code for HELP code here you write. After that, only 4 codes you write here. Then you write here count less than 3 because for fish FISH only 4 is sufficient. 0th, 1st, 2nd and 3rd data in the 7 segment. So load code of FISH, give here 3, then it will display your on the display it will show F, next I, next S, next H. So like that you can display any other alphabets if it is possible to represent, like HELP, HELP also you can display, FISH you can display. So like that you can display any desired message.